Hi everyone, in today's lesson we're going to talk about a new figure called an ellipse. By definition, an ellipse is the set of all points P in a plane such that the sum of the distances of P from two fixed points in the plane is constant. That's a fancy word for saying an oval shape. Now we can have an oval that opens horizontally, or we can have an oval that opens vertically. So let's just do the horizontal one first. So let's say the center is at the origin here, 0, 0. A horizontal ellipse would be one that opens long ways, like such. And the special characteristics of this are as follows. This point right here and this point right here on the longer side are called vertices. So we can call this vertex 1 and we can call this vertex 2. So vertex 1 and vertex 2. And the distance from the center to each of these vertices is A units. We use A to represent that letter. Now my picture's off a little bit. This should be identical spacing, but I'm doing the best I can here. All right, so the distance here and here is B units from the center, and these are called co-vertices. So this we'll call co-vertex 1, and this one we can call co-vertex number 2. And that's generally the main components of an ellipse that opens horizontally. Now we can do an ellipse that opens vertically. So let's again say that the center is at 0, 0. A vertical major axis, or an ellipse that has a vertical major axis, opens this way and makes an oval shape like such. And now, since we're opening vertically, the vertexes are going to change. So the one up top is vertex number 1, and the one on the bottom is vertex number 2. And these values here and here are your co-vertices. So we can call this co-vertex 1, and we can call this co-vertex number 2. And again, the distance from the center to each of these vertices are in fact A, and the distance from the center to each of the co-vertices are B. And that's kind of the main components that make up these two types of ellipses. So let's talk more about some key features. A is always the distance from the center to each of the vertices. So if we're opening horizontally, this is A, and that's our distance. If we're opening vertically, this is A, and that would be the distance from each of the centers. B is the distance from the center to each of the co-vertices. So here is B, here's the distance from the center to each of the co-vertices. Now C is the distance from the center to each of the foci. Now these foci are those constant points in this definition up here. So I can explain that a little bit more in class, but the foci, just so you have them, are always on the axis that the vertex is on. So we can label this as foci 1 and foci 2. Over here, foci 1 and foci 2. They're always inside the ellipse. Then we have that the vertices are the endpoints of what's called the major axis. So here, our major axis would be horizontal here, since that's where the endpoints of the vertices are, here and here. So this would be my major axis. Then if the vertices are here and here, this would be my major axis in my vertical ellipse. And the distance of this major axis is actually the distance from here to here. So since both of these distances have A and A, we can just add them together, and that distance would be 2A. The co-vertices are the endpoints of what we call the minor axis. So my minor axis is from here to here, where the co-vertices are. So I could call this my minor axis. And over here, my co-vertices go from here to here. So that would be my minor axis. And the distance from covertice to covertice is 2b's, so b plus b will give me 2b. And last but not least, if I ask you to find the value of c, or the foci, where they're located, they are c units from the center. So from here to here would be c, and from here to here would be c. That would be my foci. We can find it using the formula c squared equals a squared minus b squared. All right, I know that was a lot to take in, so now let's try to slow it down a little bit and look at the formulas. So, in order to have a horizontal ellipse or a horizontal major axis, our equation will look like this. It'll be x squared over a squared plus y squared over b squared equals 1, when a is greater than b. So we have a horizontal major axis when a is greater than b, or in other words, when the larger number would come first. We have a vertical major axis and a center at the origin when we have x squared over b squared plus y squared over a squared equals 1. So in this case, we will have this when b is less than a, or in other words, when the larger number comes second. So a is always the larger number. So we could write that down. A is always the larger number. A or a squared, the denominator is always the larger number. So we know that the center is at the origin because it works very similarly to if we had a circle, right? If we had a circle that was x squared, y squared, since there is no plus or minus values, we're not going to have a center but at the origin. So if I want to look at a couple of equations and I want to determine some information about it, we can do that. So let's look at this first ellipse. First, we want to ask ourselves, where is the bigger number? Notice the bigger number is second. So since the bigger number is second, we know that this 16 will represent the a squared. Therefore, the 9 will represent the b squared. And since the larger number comes second, we are going to have a vertical major axis, just like we have over here when the larger number comes second. So the center we know is at 0, 0. And in order to find a, we just have to take the square root of a squared. So if 16 is a squared, then 4 is a. And if we want to find b, we just take the square root of b squared. And since b squared is 9, b must be 3. So let's look at example number 2. Find the larger number. The larger number comes first. Therefore, since the larger number is first, we have a horizontal major axis. Again, the center is 0, 0. And since the larger number is a squared and the smaller number is b squared, we can just take the square root respectively to find the a and b values. All right, now I think we're ready to do a graph. So let's take a look at the first problem. I want to graph this. Well, first we have to decide where is the bigger number. Is the bigger number first or second? Well, the bigger number is first. So we know that it would be x squared over a squared plus y squared over b squared equals 1. A squared is always the larger number. So if the larger number comes first, we take the square root of that. We get 5. That goes in for a. We take the square root of 16. That gives me 4. And that would be the smaller number. So since the larger number is coming first, we know we have a horizontal major axis. The x squared and y squared have nothing next to them, so it's just going to be 0, 0. So now to find the rest of this information, we probably should graph. So we'll start at the origin for my center. And since we know we have a horizontal ellipse, we know it has to look like this. So the major axis is from here to here. We know this distance is a, and these will give us our vertices. So we can call this V1 and V2. So we're going to go over our a distance. Our a distance is 5. So we're going to go 5 to the right, 5 to the left. Vertice 1, vertice 2. B is the distance of 4, and B is the distance from the center to the co-vertices up here. So B and B, we'll call this CV1 and CV2. So since the B value is 4, we're going to go ahead from the center and go up 4 and down 4. And we'll label this co-vertice 1 and co-vertice 2. And if we connect, we get an ellipse that opens horizontally. So all we have to do is write down the coordinates of our vertices, left 5 and right 5. Those points would be 5, 0 and -5, 0. The co-vertices will be the distances up here and here, or the coordinates rather, so up 4 and down 4. So those points would be 0, 4 and 0, -4. And then the length of the major axis and the minor axis. Well, the major axis is where the vertices live. So the major axis would be from here to here. So we'll call that major. And obviously, if this is 5 and this is 5, that distance is 10. Then our minor axis is where the co-vertices live. So this is minor. And if this is 4 and this is 4, that distance should be 8. And then last but not least, if I ask you to find the coordinates of C, the foci are C's, we're going to use the formula C squared equals A squared minus B squared. So the A squared is the first number, so that's 25. The B squared is the second number, that's 16. And when we subtract them, we get 9. And if we take the square root, we get that C is equal to 3. So what that means is we're going to go 3 on the major axis, -3 on the major axis. This distance from here to here is our C value. And those are foci 1 and foci 2. So those coordinates are the points -3, 0 and +3, 0. So that is it. That is the graph of a horizontal ellipse. So what I'd actually like you guys to do right now is see if you can graph this example of a vertical ellipse, and we'll go over it in class tomorrow. All right, that's it. Have a great night.